Let's look at the equation y equals 2x plus 1. In this equation, you'll notice that there are two variables, the x and the y. For every value of x, there is a unique value of y. Here's what I mean. Let's just say x equals 3. Let's say x equals 3. So I'm going to solve by plugging 3 into x to figure out what exactly is y. All right. 2 times 3 is 6. 6 plus 1 is 7. So that means y equals 7. So every time I plug in 3 for x, I will get y for 7. This means that x is your input. X is your input, but y is your output. Every time I put 3 into x, I get 7 out of y. Another term that could be used for input is the domain. The domain is your x value. Output, another term, range. So range, output, and the y value are all synonymous of each other, while domain, input, and the x value are all synonymous. Let's talk about how to find the domain and range. In this example, I'm going to give you a relation. A relation is a set of ordered pairs. A set of ordered pairs. A set is only 2 or more. So in this set, I have 3 points. And let's say I'm asked to find the domain. Remember, the domain is all of your x values. So I just list them in order from least to greatest. 2, 3, 4. Let's find the range. Your range is all of the y values, and you always list them in order from least to greatest. So 1, 2, 5. All right. That is your domain and your range. The next thing that we would want to know is this relation a function? Is this relation a function? The way that we would figure out if the relation is a function is by looking at the x values. We're looking specifically at your x values. Do any of these repeat? If none of the members of the domain repeats, it is a function. If none of the members of the domain repeats, it is a function. Let's look at another way. I'm going to take these 3 points and I'm going to turn it into a table. So my x's, 2, 3, and 4. My y's, let me take that line away. Let's do it different. My y's, 1, 2, 5. I don't want to get ahead of myself. So let's connect them. 2, 1, 3, 5, and 4, 2. Notice each of these x's goes to its own y. None of them share. For example, there is not a 2, 1 and a 2, 2. The 2 has to go to its own y. All right, so it cannot be 2, 1 and 2, 2. Now it could be the other way around, but it cannot share. The x's cannot share. None of the x's can repeat. Let's look at it another way. This may be easier for some of you that are visual. Let's look at a vending machine. Here in this vending machine, you'll notice that there are numbers. If I press a certain number, I get a certain snack. For example, if I press the number 31, I get a Snickers bar. If I press the number 15, I get a Doritos bag of chips. However, if I press 15, I cannot get a bag of Doritos and a Snickers bar. When I press 15, I get one thing out. I can't get 2 different things out. That is what makes it a function. That number 15 has to go to one unique item. Same thing with number 36. Number 36 is the chocolate candy Twix. When I press 36, I'm not going to get Twix and Doritos. I'm only going to get the Twix. That is what makes it a function.